Okay, so we're going to start the second day of the first week of respiratory system by talking about mechanisms of pulmonary ventilation. So here are the three outcomes for this lecture. So first we're going to start about Boyle's Law, talk about Boyle's Law. Some of you have probably heard about this, especially if you've taken chemistry before. Okay, so here we've got Boyle's Law, and got to use this terrible joke that I heard from my chemistry teacher in high school. His name was Marty Monson, one of my favorite teachers ever. And Boyle's Law, obviously named after Mr. Law. That was his whole thing, is that every law or number or whatever was named after Mr. Law, Mr. Number, Mr. Equation. Obviously not. This is Boyle here. He's got some sweet hair, and since I'm losing all my hair, I would never want that much, but maybe I'd take that much. Basically what Boyle's Law says or talks about is the relationship between the product of pressure and volume. So if the volume of a gas increases, then the pressure decreases. And we've already applied or utilized Boyle's Law. We talked about it a little bit last time when we were talking about inspiration and expiration. Okay? But the sum of that, or that product, will remain constant if we're in a closed system. And so your lungs and your thoracic cavity, that's considered a closed system. All right. So with inspiration, we're going to tie this in. When I contract my inspiratory muscles, such as the diaphragm, that increases my thoracic cavity volume, which will decrease intrapleural pressure. It will also cause an increase in lung volume. Basically, we're pulling open those alveoli. So as a result, we decrease alveolar pressure. Air goes into the lungs. That's Boyle's Law being applied. Okay, and this continues until alveolar pressure matches atmospheric pressure. Air stops flowing into the lungs. Unsurprisingly, expiration is the exact opposite. So I relax my diaphragm. That decreases thoracic volume, causes intrapleural pressure to increase and lung volume to decrease, which causes an increase in alveolar pressure. Air flows out of the lungs until alveolar and atmospheric pressure are equal, and then it stops. Okay, again, this is applying Boyle's Law. So when it comes to ventilation, there are a few things that affect how easy ventilation occurs. And so we've got several things here. So we've got smooth muscle contractions. So just think about the airways. Are they dilated or are they constricted? We've got the concept of compliance. The fact that the lungs themselves are designed in a way that they want to recoil. Surfactant and surface tension. Okay, so with each of these, I just want you to be able to identify, does this make it easier to get air in or air out? So the first one was that the diameter, or what would we say, smooth muscle contraction. So that'll affect the diameter. So I want you to take a look at this figure here. And we've got one person, two conditions. One where we've got increased resistance and one where we've got normal resistance. Notice in both cases they're taking the same amount of air into their lungs. But what's going on with pressure? So first of all, what contributes to this increase in resistance? Airway radius. Remember, radius has the greatest effect on resistance. So what do you think it's called when we increase airway diameter? Okay, if we increase diameter, it's bronchodilation. If we decrease it, it's bronchoconstriction. So when we increase resistance, well, how does this happen? When would we have a narrowing of those airways? This would happen, or this is what happens when someone has asthma. Okay, I've never had asthma, so I don't know what it's like, but asthma can be like you're trying to breathe through a straw. Not great, not fun, sounds terrible. All right. If my airways are, the radius of my airways is reduced, in other words, I have greater resistance, how can I maintain flow? And the answer is I can generate more pressure by using more expiratory muscles. A lot of times it's very difficult for people to get air out. Okay? But even this isn't enough. And the problem is that you don't have to have a very large change in radius to cause a very large change in pressure to maintain flow. Okay? So if I narrow that, it's going to make it difficult to get air in and out of the lungs. So compliance. Well, compliance is just simply put, how easy is it for a vessel, a container, or for something to stretch to increase its volume as it fills up? And the formula is delta V, which is change in volume, over delta P, change in pressure. Okay, if something has high compliance, you're going to get a big change in volume for a small change in pressure. Okay, imagine inflating a paper bag compared to inflating a paper balloon. You just want to increase the volume, fill it all the way up. What's going to be easier? The paper bag is, okay, compared to the balloon. So paper bag has very high compliance. The balloon does not. Compliance and elasticity are kind of the opposite, okay? But you don't want too much compliance. You don't want too much elasticity. So think about paper bag. You inflate a paper bag. Well, what do you have to do to get the air out? You have to use a lot of pressure, right? Like the bag's not going to recoil. And so you actually have to create a lot of outside pressure to get the air out. And so if your lungs are too compliant, then you can't get air out. You have to generate massive amounts of pressure. This is what happens to smokers. They basically make their lungs super compliant. So they can get air in as much as they want. They just can't get that air out. Next, we've got surface tension. So surface tension is basically how much is a measure of how difficult it is to increase the surface area of a liquid. All right. If you have high surface tension, then that means it requires a lot of work. Surface tension counteracts compliance. Okay. Surfactant decreases surface tension. Now, water has very, very high surface tension. Okay, with my graduate class earlier this semester, I dumped a little bit of water onto a table, which is probably frowned upon always, but especially with COVID. But that water didn't just run off the table. It beat it up kind of in the center, right? And you dump a little bit of water on your table or whatever, and there's that, you can see the thickness to it. That's because of surface tension. Okay, surface tension is one of the qualities of water that makes life possible, but we're not going to get into that. Surface tension is good because, well, it increases the recoil force, which is good. That means that we can get air out of our lungs. But again, we don't want that to be too much because then it'll be difficult to get air into our lungs. And so we counteract this increase in surface tension with surfactant. Surfactant is just some substance that breaks down or eliminates or reduces surface tension. This is what detergents do, what soaps do. They break down the surface tension. Okay. Now, just to give you an idea of how surface tension works, we've got the law of Laplace, and so this is Mr. Laplace here. And so he had this formula that said the pressure to prevent collapse. It's really weird. It's worded uniquely, or maybe a little difficult. Okay, I can't talk. Is the pressure required to keep something open is 2 times the surface tension divided by its radius. And so the bigger the radius, the less pressure is needed to keep it open. This is why big bubbles last for a long time and small bubbles don't. They don't need as much pressure to stay open. Next, we have the rib cage and the lungs. As we've talked about a few times, the lungs want to recoil, and this is because they have a lot of surface tension, and due to the fluid that's in them, the elastic fibers that we've talked about, that sort of thing, and so the lungs want to collapse. So this makes it easy to get air out, but surfactant in the alveoli kind of counteracts some of that surface tension, that recoil. So that's going to make it easy to get air in, or easier. And so there's this nice balance. Whoops. And then the ribs themselves, they want to expand. And so they open up your alveoli, decrease the pressure in your alveoli so air can get in more easily. So can you do these 3 things? Talk about Boyle's law. What are factors that cause or allow air to get in, factors that allow air to get out, and what is compliance?